Welcome to Complexity Made Simple. My name is Paul Allen, and today we're going to do a software tutorial. We're going to take a look at the software of choice that I use in Six Sigma. We're going to look at SPC XL. Hope you enjoy it. Okay, welcome to Complexity Made Simple again, and the subject of today's tutorial, we're back with Sigma Zone and SPC XL. And today what we're going to look at is we're going to look at sample size, and we're going to look at the sample size calculator in Sigma Zone. Just before we look at sample size, I've just set up some data here just to show you what sample size does to the quality of your estimate. So I've got some data here over in the green fields, model 2. I've calculated the average for the sample data that I've got here, look. So the average, look, in that data set is 50.98. And then what I've done is I've taken a sample from that group of 10, a sample of 20, and a sample of 80, and I've worked out the average for those. Now look, the sample of 10, 50.65, is 0.3 away from the real average in the data. So quite a long way away. If I take a sample size of 20, I start to get a lot closer to the real average. And if I take a sample size of 80, now 80 is quite a large sample size. I wouldn't recommend that you take a sample size as big as this. 50 is probably all you need. You can see once we take a proper sample size, we start to get nice and close to the real value. So if you don't take a proper sample size, basically you start to guess. The data that you have is a very poor guess of what's happening in your process. Saving on sample size does not come free. You take risks, and you take risks with your business, you take risks with your process. So the more you cut the sample size, the bigger the risk you take. So when I teach sample size in class, I don't normally teach my clients to work out the sample size. I typically give them a rule of thumb. If you're using measurable data, then the sample size is going to be anywhere between 30 and 50. And if you're in that region, you're going to be making a pretty good guess of what's happening. If you choose to come outside that region, you bring your sample sizes down 20, 15, 10, 5 even. People that make prototypes often go to 5. That is a complete guess of what's going to happen. You take a huge risk that when you go into production, you won't get what you're expecting. So, okay, I do use a rule of thumb, 30 to 50, but let's show you how the real sample size gets calculated. So I'm going to go Analysis Tools, and down the bottom here, look, Sample Size, and the top one is for the mean. That's what we're dealing with here. So if I do that, it brings up this window, and it wants 3 pieces of information. It wants you to estimate the standard deviation. It wants you to define the half interval width. In other words, how close to the real value do you want to get? How good do you want your estimate to be? And also, statistically, what confidence level would you like? Okay, so they're the 3 bits of information. Now the first one, the standard deviation, it says estimated standard deviation. There is a reason why it says estimated standard deviation. Obviously, you haven't taken a sample yet. So you don't necessarily know the true standard deviation of what you're going to see. So you have to give it an estimated or a planning value of some kind. Now you could get this value from history, a similar product made on a similar machine. You could get it from your tolerances. You could take your tolerance, your total tolerance, and divide it by 6 and put that in. You could use that as a planning value. Or in this case, what I've done, look, is I've taken a little pre-sample. I've taken 10, and then I've worked out the standard deviation, and I'm going to use that, and then I'm going to work out the proper sample size. So in my case, the standard deviation is 1.28, and we're going to use that. So in the first box, I'm going to put 1.28. Then the half interval width. Now this is a practical thing. How close would you like to get to the real value? Now I want to get 0.3 0.3 of a decibel. That's as close as practically I need to be. That's a good value to be. And for a 95% confidence interval, as close as 0.3 of a decibel, when I'm seeing a standard deviation of 1.28 decibels, it's recommending a sample size of 70. So a little bit outside the rule of thumb that I use. That's probably because I'm asking for the estimate to be quite close compared to the standard deviation value. But 70 is the calculated sample size. And that is in order to get an accuracy in your data set that you are happy with, and you are not taking risks with your business. You are not taking risks with your processes. Don't forget, you are about to save 30 pieces here. So if you choose to violate this number, if you choose to take 10 or 15, you are about to save the cost of just 50 items. When you put the item into production, you could waste thousands and thousands of items once it goes live. This is not saving money here. This is taking a huge risk. Use proper sample sizes. Get a good estimate of what's going to happen going forward. Then when you switch your manufacturing processes on, you won't get any nasty surprises. Sample size calculation.
Well, I hope you found that useful. If you've got any questions about that topic, or indeed anything to do with Six Sigma or Lean for that matter, give me a call and I hope to hear from you soon.